The species alive today make up less than a percentage of the species that once sprawled across our planet. While the natural background extinction rate claimed many of those we've lost, this rate of extinction has also been continually punctuated by catastrophes. Asteroid impacts, climate change, tsunamis, droughts, and the fishing industry are but a few catastrophic phenomena that are more than capable of wiping out thousands of evolutionary lineages at once. But there's another threat lying quietly in the earth that's easy to forget. A threat that's seemingly so benign to us that we build entire cities on top of it. Until inevitably one day it isn't. Supervolcanoes are up there with asteroids in the worry category of what are you gonna do? They're enormous, almost entirely unpredictable, and when they hit, they are potentially destructive enough to wipe us out. And around 74,000 years ago, some say one almost did. This is the story of the recent Toba eruption, and in this video we'll be covering its potential, the mess it made of the place, and if and how it might have reduced the human population to its knees. And stick around because while the Toba eruption clearly didn't finish us off, we're going to end with a nod to one that just might. But first, let's head over to Indonesia. There is very little around Lake Toba, Indonesia that isn't breathtaking. Today, this location is home to a stunning and tranquil atmosphere, where hundreds of thousands of people are dotted about on the edges of a vast blue lake 500 meters deep. This lake is framed by tall, velvety green mountains that channel waterfalls of crystal clear water into it. And right in the middle is the tropical Samosir Island, sparsely populated with rural, traditional homes and farmsteads. This warm and friendly paradise is also an ecological haven for unique and diverse flora and fauna. And yet, not too long ago, in terms of the biological history of our species, it was the scene of a devastating catastrophe that could have come close to wiping out our entire race. Looking at Lake Toba from the ground, or even as high up as the mountainsides themselves, it would be difficult to tell that you're standing on the edge of a volcanic crater, 100 kilometers long and 30 kilometers wide. And even from above, looking down at this enormous chasm, it's hard to imagine the lush green and wet landscapes beneath you are the result of a terrible scar left by the most powerful of natural forces. Because this gargantuan hole in the earth was ripped open by the largest explosion in 2.5 million years, and one of the largest in the history of the earth. This explosion was caused by the Toba supervolcano. But what is a supervolcano? Technically, a supervolcano is any volcano with an eruption that ranks a number 8 on the Volcanic Explosivity Index. But this is sort of tautological since the index is only there to describe volcanoes in the first place. So what does an 8 on the index mean? Well, this refers to the volume of the ejecta, or the amount of stuff that came out of the volcano. And in this instance, an 8, the highest rank on the index, refers to anything from 1,000 cubic kilometers upwards. So a supervolcano is one that exploded with enough force to send out a quarter of the volume of the Grand Canyon at least, all in one go. That's enough matter to coat the entirety of Great Britain in 4 meters of ash, and that's only the lower boundary of the highest rank. The largest of these volcanoes is thought to have been responsible for popping a continental zit, almost twice the volume of the entire Grand Canyon. And that's more force than we can really get our heads around. These unthinkable explosions are the result of a buildup of pressure over time, as magma tries to escape through the crust but for some reason can't. Eventually something has to give, and that something is always the continental crust. 1,000 cubic kilometers or more of it, as is the case in a supervolcano. And this isn't just a hypothesis, it is as conclusive a fact as you can find in geology. Not only did it happen in Toba around 75,000 years ago, it's happened multiple times over the world, and some were even bigger. 2 of the largest known come about from present-day Colorado and Utah, having erupted sometime around 28 and 30 million years ago respectively. These were both during the Oligocene, and both events ejected more than 5,000 cubic kilometers of matter. Some of the deposits around these craters are 4 kilometers deep, with the volcano having laid down thick blankets of destructive ash, debris, and lava that would have destroyed any life beneath it. But it's not just the hard stuff to worry about with explosions like this. The long-distance slaughter comes as a result of gas. When a supervolcano erupts, it doesn't just spew out rock and ash, it also sends out a bunch of sulfur dioxide, high into the atmosphere where it reacts with water to form aerosols. These are tiny but very reflective particles that send the incoming sunlight back away from the planet. The result is a sudden and prolonged drop in sunlight, and therefore the drop in global temperatures that the sunlight was maintaining. This is known as a volcanic winter, only unlike a regular winter, it may not end in a single season. This too is well-established fact. In 1815, Mount Tambora erupted in Indonesia. It filled the air with so much junk that the entire world was affected. The eruption occurred in April, and the effect lasted until 1816, the following year, which became known as the Year Without a Summer. Summer temperatures in Europe were colder than any on record for the time, and worldwide people suffered crop failures and the ensuing riots and famine that come from that. This global agricultural disaster killed over 100,000 people, and it was caused by a volcano powerful enough to eject a mere 45 cubic kilometers of matter into the air. So if a volcano 100 times this powerful erupted, what would happen? Well, one proposed outcome is that humans would get totally screwed. Genetic bottlenecks occur when populations are significantly reduced for whatever reason, and humans carry with them evidence of such events in their DNA. Flirting with extinction leaves marks on an organism's genetic makeup. With fewer individuals to choose from, animals breed with the best they can find, and this results in their offspring suddenly having very similar genes across the population. In humans, our genomes still carry the echoes of our own ancient crises, and these echoes have allowed researchers to identify several possible bottlenecks in our evolutionary history. Genetic analyses suggest that almost 1 million years ago, for example, our ancestors were reduced from around 100,000 to a population of around 1,000 breeding pairs, and they stayed isolated and restricted from increasing in number for over 100,000 years. Nobody knows how or why this happened yet, but whatever caused this rapid reduction seems to have almost wiped out our species line entirely. Of course, fortunately for us, around today, those 1,000 pairs would eventually rebound. Similar genetic investigations undertaken in the 1990s to the early 2000s unearthed clues that a similar reduction in population occurred far later, around 75,000 years ago. And this apparent genetic bottleneck seems to coincide neatly with what researchers now know about the eruption of the Toba supervolcano in Indonesia. The recent Toba eruption wasn't recent in the same way that the new Liam Neeson comedy is recent, but for supervolcanic eruptions it is as recent as we would want it to be. In 2.5 million years there was no explosion bigger, and unlike those before 2.5 million years ago, this one was slap bang in the middle of our species' progress out of Africa. There are no written records this far back, but given that the Tambora explosion was heard perhaps as far away as 3,500 kilometers from the volcano, it's likely Toba would have been pretty loud, to say the least. Those within several kilometers of the mountain would have been killed before they had even known what was happening. A shockwave shooting out well ahead of the sound of the explosion would have flattened the land around it and wiped out any communities nearby. And while there were no known modern human communities in that part of the world at the time, there would have been Denisovians who had entered Asia as far back as 285,000 years ago. Still, modern humans were around in Africa, and this is where we see evidence that the impact of Toba made its way well across the planet. Let's take a look at how the whole thing played out and talk about the lasting effects. Some years, perhaps even centuries before the eruption, the land above the Toba complex of magma reservoirs, where modern-day Sumatra currently sits, would have started to dome. At least 5 of these reservoirs would have contributed to a massive pooling of magma, pushing upwards from the mantle and driving the pressure up. At its onset, a stream of tiny glass particles and ash would have pushed from the Earth into the atmosphere, the first sign that a crack was forming in the crust, and within a day or two, all hell would break loose. Glowing walls of pyroclastic ash and glass, ejected at hundreds of kilometers per hour. Plumes of ejecta reached over 32 kilometers into the air, and as the roof of the magma chambers collapsed, another wave of ejecta shot outward from the crater. Ash continued to fall for weeks afterwards, and a fortnight after the explosion began, a final venting of sulfur dioxide into the upper atmosphere occurred. The total volume of ejecta from Toba is estimated to have been somewhere just shy of 4,000 cubic kilometers. That's roughly the entire volume of the Grand Canyon. And in case it helps, the Grand Canyon has vastly more space than the entire volume of all the people on Earth who have ever lived. The lava flow that spewed from this oozing wound coated an area of up to 30,000 square kilometers with a sticky layer of rock up to 100 meters thick. From the sky, the entire Indian subcontinent was covered in 5 centimeters of ash. The South China Sea, all of it, got 3.5 centimeters of ash, and in total 7.5% of the entire surface of the Earth took a serious sprinkling from this one volcano. But this would have been just the beginning. Ice cores from Greenland suggest that around 75,000 years ago, this final venting of sulfur dioxide may have triggered the onset of a cooling that would last 1,500 years. But how would this have affected our species? In 1998, Stanley Ambrose popularized what would become known as the Toba catastrophe hypothesis. This was the idea that the massive eruption of Indonesia's Toba supervolcano triggered a volcanic winter so severe that modern humans outside of Africa were reduced just to a few thousand mating individuals. The puzzle pieces did seem to line up behind this claim. Genetic analyses showed surprisingly low diversity in human mitochondrial DNA, and the size of the eruption was predicted to have caused a volcanic winter of 7 to 10 years. Add to this Greenland's ice core evidence that cooling did indeed occur around this time, and the hypothesis had a fair bit of support. It wasn't just humans either. Other great ape populations appear to have faced similar effects. The eastern chimpanzees, the gorillas, and the Bornean orangutans all appear to have expanded from very small populations at around the time of the Toba eruption, as did macaques, cheetahs, and tigers. And it meets our intuition as well. The image of a sleeping monster the size of a city, resting ominously beneath our settlements, is definitely inspiring, and given what we know about the effects of far smaller explosive eruptions, it's not hard to imagine a globally devastating explosion jeopardizing any and all life by blocking out the sun with ash and gas. But over time, this hypothesis began to unravel a bit. For one thing, the global cooling event evidence from the Greenland ice cores now appears to have begun before the eruption. Further, simulations suggest that the volatile emissions were actually far lower than was originally estimated, by several orders of magnitude even. And finally, archaeology across the Indian subcontinent appears to contradict the hypothesis quite strongly. There are stone tool assemblages from this region, from before, during, and after the Toba eruption, indicating that the volcano had very little impact on the humans in the region. But the bottleneck is real, and the Toba eruption is real, so what exactly happened? There is indeed an apparent genetic bottleneck in human DNA, and it looks to have occurred somewhere between 70 and 60,000 years ago. But this is now thought to have arisen as a result of a population bottleneck as our species left Africa on the most recent and successful migration out of the continent. What this essentially means is that while the human population outside of Africa emerged from a tight bottleneck, thought to be somewhere between 1,000 and 5,000 individuals, this wasn't because of something that wiped out the remaining population, but simply because that's how many people were part of that particular migration. As this group expanded out into Eurasia, a lack of gene inflow resulted in a lack of heterozygosity in their offspring. And to back this up, when compared with the African populations, this drop is starkly more obvious. I.e., there was a marked reduction in genetic diversity, but it wasn't as a result of a catastrophic event. Kind of an anticlimax, right? But all is not lost, because while the Toba eruption wasn't responsible for nearly wiping out all of humanity, Yellowstone may well soon be. Before we touch on this, here's a routine interruption to say that we hope you're enjoying these videos, and if you are, please click on the like button to bump them up in the algorithm. And if you haven't already, please also consider joining our subscribers to see more of them. Now, back to America, and Yellowstone caldera was the setting of multiple eruptions like Toba, beginning around 2.1 million years ago, and proceeding through 3 major cycles, each one producing continental-scale ashfall, immense lava flows, and no doubt upsetting any communities of animals living around it for thousands of kilometers. The most recent super-eruption was around 630,000 years ago, and since then there have been some puffs and lava spills, but nothing on the scale of a super-eruption yet. But it is only a matter of time, and this volcano is thought to have at least one more in it. The question then is simply when. While it's commonly said to be overdue, this is still talking on the scale of centuries to millennia, so the chances of it popping off in our lifetime are slim, but they're not zero. And Yellowstone is perhaps just the best known of the bunch. There's also Cerro Galán in Argentina, Valleche in New Mexico, and Taupō in New Zealand to think about. Not to mention Toba itself, which is currently refilling its magma chambers, though this may take around 600,000 years to complete. So it's unlikely that Toba wiped out the whole of humanity, and it's unlikely that it will anytime soon, but that's not to say that one day it, or others like it, won't. Meanwhile, we will continue as a species building cities and entire communities on top of these magma pools, for the most part blissfully unaware of the potential danger beneath us. And that's all for this video. Thanks again for watching, and we'll see you for the next one.